When a high-scale data incident strikes a platform, engineers must act quickly to move corrupted data, rewrite permissions, and repair paths. But a single misplaced terminal flag can turn a routine repair into a disaster. A recursive delete executing against production data can lock out an entire organization in seconds. To solve these issues, engineers historically followed a standard workflow. They would acquire a powerful superuser credential directly on their local machine to run necessary commands. The problem is that local possession of a master credential bypasses command-level guardrails. Once the token is on the machine, there is no technical check on the operator's logic. This also obscures the audit trail. System logs record a shared superuser making the change, hiding the specific individual responsible for the operation. Securing the system requires a different approach. The privileged credential must be completely decoupled from the local operator. Zero Trust for infrastructure management requires routing emergency terminal commands through a gated pipeline before they ever reach the production environment. In the legacy model, a local machine node follows a direct path to the cloud storage endpoint. Because this connection is direct, there is no space for peer review or automated oversight between the command being typed and its execution. Execution logs only showed destructive actions performed by a generic account, with no human names attached to the entries. After an incident, forensic teams are left correlating separate login logs with execution logs to try and identify who ran which command. Centralized policy enforcement is impossible when the administrative privilege resides on the same terminal used to initiate the change. Relying on human precision during high-stress, late-night incidents is a systemic failure of architecture, not a failure of the individual operator. To address this, Uber introduced a CLI wrapper designed to intercept high-impact commands before they run. From the engineer's perspective, the process feels familiar. They type the same command as before, but it does not execute on their machine. Instead, the wrapper captures the command and generates a pull request URL. This PR is routed to a centralized Git repository, specifically dedicated to managing infrastructure commands. Choosing Git over a custom database-backed approval system was a deliberate architectural choice. Git provides a mature interface for peer review and creates an immutable history of all requested changes. This setup also allows the gateway to integrate with existing CI automation pipelines to run safety checks on every command. The engineer can then tag their teammates for review, bringing the same rigor to infrastructure changes that they apply to software code. By treating CLI commands as pull requests, unpredictable infrastructure changes are brought into a standardized and auditable lifecycle. The moment a PR is generated, a suite of automated validation jobs begins to run. These jobs check the command syntax and verify that the user has the appropriate internal permissions to perform the request. But the most significant safeguard is a process called automated impact estimation. A CI job queries the underlying file system image to simulate the effect of the command without actually changing the data. The system calculates the exact blast radius, such as the number of files scheduled for deletion, and posts that data as a comment for the reviewer. Forcing a human reviewer to see an automated calculation of the impact helps prevent the kind of catastrophic approvals that happen when context is missing. Even with an approved PR and passing CI checks, the engineer's machine still lacks the power to execute the command. Execution is handled by a remote execution service, a back-end system completely isolated from the user's environment. This service independently verifies the approval status of the PR before it begins the execution process. This backend is the only entity in the system that possesses the superuser credentials. It executes the approved command against the cloud storage layer on the user's behalf. The system then pipes the standard output from the backend back to the local terminal, giving the engineer the feedback they need. To maintain operational efficiency, this gated workflow is used for state mutating writes, while read-only debugging uses a separate path with lower friction. True privilege isolation ensures that the human operator never touches the administrative credential, even when they are the one directing it. This end-to-end pipeline, from the CLI to the Git PR, through CI validation and human review, creates a secure path for critical operations. Throughout this process, the local machine remains completely unprivileged. This provides accurate attribution, as every state change in the infrastructure is tied back to the specific initiating engineer. The architecture mitigates the risk of catastrophic errors by requiring a multi-party authorization consensus for every write command. Securing infrastructure isn't about stopping necessary work, it's about providing a safer conduit for that work to occur. If your infrastructure still relies on engineers typing ungated commands into privileged local shells, it is time to build a gateway.